All right, so today we're going to be looking at three different types of solutions and how to identify if a solution is one of these three types. So there's three ways to classify a solution. It can either be unsaturated, saturated, or supersaturated. So unsaturated means it can dissolve more solute. That means it has not reached capacity yet, and we still have room to grow. So if we're looking at a solubility curve, which we'll look at in just a few minutes, this is going to be below the line. So if we have a value that falls below the line, that is unsaturated. It has not reached that capacity yet. And a visual would be something that completely dissolves. You cannot see any of the solute in there. It is completely dissolved. Saturated is when a solution contains the maximum amount of solute. You cannot add any more before it starts sinking down to the bottom. This is on the line of a solubility curve. So this is the line, is saturated. And if we're in the lab, this is where we start seeing a little bit of crystals falling out of solution. This is like if you're mixing some sugar into tea and all of a sudden you notice that it is not mixing as well, that's probably your saturated point. Not where we have huge lumps, but just a little bit. Supersaturated means that you have put more than it can possibly hold in there. You have exceeded the capacity. It is now oversaturated. This is, as the name suggests, super is above and beyond. So this is above the line. This is where we start seeing really big crystals forming, okay? We've put so much of this solute in there that absolutely no more can dissolve, and beyond that, some of it's falling out of solution and forming these crystals. So we're going to take a look at some of these examples. Supersaturated solutions means that it's holding more solute than it should be able to. This is achieved by heating the solution and then cooling it down slowly. This is a very delicate process, so we want to make sure that we're very gentle with it so that it's not falling out all at once. So some examples of this are rock candy, southern style sweet tea, chemical heat packs, things that we heated them up and then we gently let them cool down. We don't immediately immerse them in an ice bath. We don't immediately pour that sweet tea over some ice. We try to let it get down to room temperature first. Supersaturated solutions are very unstable. All that solute that you have packed in there wants to be free. It does not want to be trapped in that solution. So if you don't take great care, then it's going to fall out of solution. The supersaturation is only temporary. Eventually, we're going to get crystals like this rock candy or like these snowy crystals in this flask right there. All right, so an unsaturated solution, it can dissolve more than what it already has. Saturated, no more can dissolve. It's at maximum capacity. Supersaturated, unstable, crystals start forming. Basically, we have exceeded, gone above and beyond what it should have been. So as we get closer to supersaturation, we are increasing in concentration. This is a very low concentration with the unsaturated solution. This is a very high concentration with supersaturated. So here's an interesting video that I found that shows what can happen with supersaturation. Basically, this guy has some sort of solution, and as he's pouring it out onto the desk, all of that solute is falling out as crystals. Pretty cool. All right, so this is a solubility curve. This is where above, below, or on the line comes into play. So solubility indicates the amount of solute that's going to dissolve in a given amount of solvent at a specific temperature. Temperature is a big part of solubility. If you recall on factors that influence solubility, the hotter something is, the more you're going to be able to get to dissolve, because the increased energy allows those bonds to break and allows the solute to dissolve much more rapidly. So on the solubility curve, the x-axis right here is your temperature in degrees Celsius. So we can see that it usually goes 10, 20, 30, 40, and so on. That's degrees Celsius. The y-axis is how much solute dissolves in 100 grams of water. Okay, so it's always grams of solute per 100 grams of water. And then the various lines are the different substances. So here's the one for potassium nitrate, ammonium chloride, potassium chloride, sodium chloride, potassium chlorate, and ammonia. Okay, each one is going to have its own unique line, so you have to make sure that you have the correct line when you are looking at a specific substance. Okay, so let's take a look at the line for potassium chloride, this orange one. That line represents the saturated point. Now notice every temperature has a different point. So at 10 degrees Celsius, that's about 30 grams. At 50 degrees Celsius, it's closer to maybe 43 grams. At 70 degrees Celsius, it's just shy of 50, maybe about 49. Okay, and then at 90, it's about 55 grams. Okay, so temperature plays a big part in how saturated something is going to be. If it's above this line, so if I have a point and it's above this saturated line, so if it's in this blue area, that is super saturated. That means we've gone above and beyond. We've packed more solute in there than should have been. If it's below this line, in this green area, that means it is unsaturated. So if we have a point that falls below this red line here, that's unsaturated. Okay, so let's use this solubility curve to classify these values as unsaturated, saturated, or supersaturated. So let's look at 80 grams of sodium nitrate at 30 degrees Celsius. So first, let's find the sodium nitrate line. That is right here. It's kind of this diagonal line right there. All right, so I'm going to find 80 grams at 30 degrees Celsius. So 30 degrees Celsius, go up, find 80 grams. Now, in relation to that line, is that point above, on, or below that line? Okay, so this is below the line, okay? In relation to this right here, this is below the line. That means it's going to be unsaturated, okay? So I'm going to say that 80 grams of sodium nitrate at 30 degrees Celsius, since it's below that line, is unsaturated. Let's go to our next point. 45 grams of potassium chloride at 60 degrees Celsius. All right, so I'm going to find my potassium chloride line right here. Okay? Let's go to 60 degrees Celsius and 45 grams. So 60 and 45. Right about there. Okay, now, is that on, above, or below the potassium chloride line? This one right here. So that is actually on the line. When it is on the line like that, that means it is saturated. Not above, not under, it's right spot on. So that is saturated. Let's look at another example. 30 grams of KClO3 at 30 degrees Celsius. So here's that line right here, KClO3. All right, so we're gonna go 30 grams at 30 degrees Celsius. So 30 and 30, right there. Okay, now in relation to this line, it's kind of a grayed out line. Is this one above, on, or below the line? So in relation to this line, it is above it. That means it's going to be above and beyond, or supersaturated. And then the last one, let's look at 70 grams of lead nitrate at 60 degrees Celsius. So lead nitrate is right here. This is a really dark line. Okay. So let's find 60 degrees Celsius and 70 grams right there. Okay, now as far as this line, okay, I see that this line continues all the way up here. This point is below the line, so it is unsaturated. Okay, that's really all there is to being able to read one of these curves, is interpreting where is your point, is it on, above, or below the line. All right, let's look at another one. So this is a little bit more complicated. So for every 100 grams of water, remember that's what our rules say on here, how much dissolves for every 100 grams of water. I want to know how soluble is 100 grams of sodium nitrate at 50 degrees Celsius. All right, 50 degrees Celsius and 100 grams of sodium nitrate right there. Now, let's take a look at this. Sodium nitrate. Oh dear, my line ends with the graph. Now, let's think about what's happening. Does this line just cut off right there probably? Or does it keep going if we were to extend this graph? So using extrapolation, this is a pretty straight line. I can't imagine it just stopping right here, okay? There's no indication that it would just flatline. So I'm gonna extrapolate and say it's probably still going. And if it's probably still going, like if I were to put a ruler right there, that point is gonna be below the line, which means it's gonna be unsaturated. It means all my solute's gonna dissolve, it's gonna be a nice clear solution, and we can put more in there. Now let's say that we cool it down. We're gonna cool our solution down very slowly to 10 degrees Celsius. Very slowly. We're just gonna leave it at room temperature for a little bit, see what happens. Okay, this is assuming we're in a refrigerator. All right, so we're at 10 degrees Celsius now. We still have 100 grams of sodium nitrate. Now, where is it? Is that point now on, above, or below the line? Well, now this point is above the line. So we have now gone from an unsaturated solution at 50 degrees Celsius to a supersaturated solution at 10 degrees Celsius. This is an example of temperature matters, okay? What is fine for a high temperature is not going to be fine for a low temperature, okay? Since we cooled it down very slowly and we were very delicate with it, that extra solute is gonna stay in solution and still be clear. However, it is very delicate, so we don't want to agitate it very much, or else it might end up falling out of solution. All right, let's say that instead of letting it cool down very slowly, all right, so we're backing up. So we're going back to our 50 degrees Celsius, okay? Let's say that instead we put it in an ice bath, okay? We dunk it in some ice. We cool it down very quickly. Shoo, like that. Okay, we were not very gentle. In this case, it is probably going to end up losing some of its solute. Okay, in this case, since we did it very quickly, we were not gentle with it, it's gonna fall down to the saturated line, and we're gonna have 100 minus 80 is 20 grams of extra solute sitting at the bottom. Okay, so if we take care, we're very gentle and let it cool down slowly, then we'll keep that solute in solution and it'll be super saturated. If we're not careful and we do it quickly, then it's gonna fall out and be saturated and we're gonna have some leftovers. Okay, so that's one reason why it's a good idea that if you're trying to create a super saturated solution, such as your sweet tea or something like that, let it cool down to room temperature first before you put it in the refrigerator or wherever else you're going to cool it down, okay? So don't just shock it, make sure that you're very careful with it. All right, so again, the concept of using a solubility graph is we need to identify the substance. We look for the intersection of the solubility and the temperature and look for where it is in relation to the line for that substance. So that's the main concept of using a solubility graph.